Hello guys, welcome back to my channel, Maison African Motives. Still working on O-level mathematics. In this platform, we've got the question paper, which was actually written in June 2015. So that's what we have got in this platform, guys. This is actually June 2015, paper 1 for mathematics O-level. So shall just quickly rush through the questions so that we'll see what we are supposed to actually have done to attempt these typical questions that we have got here. All right, so as we know, guys, this is paper 1. No calculators are allowed here, so which means you're supposed to use your own calculations without a calculator. No tables, no calculators. All right, so the first part is to express on question number 1. We are given here to express the given number, which is 0,0978, correct, to 2 decimal place. That is the first part, 2 decimal place. So you know that decimal places, these are digits after the comma. So in this case, we just have to count the number of digits after the comma to be 2. That is 1, 2. So the next number is 7, which is going to affect this one. And it's going to give us a 0 here. And we give a 1 here, which is going to be 0,10. So that's what you're going to have in this case as a number to 2 decimal places. So we are not supposed to leave this 0 because remember your answer is needed to 2 decimal places. So this is needed on your answer. You're supposed to have your answer like that. Okay, to 2 significant figures. Remember significant figures, these are whole numbers. So from 0,0978, the whole number, the first whole number that we have is 9. So we're going to have 1, 2. So this 8 is going to change this 7 into 8. So it's going to be 0,09. And this 7 is changed into 8. So that's what you're going to have. Then in standard form, remember that in standard form, your number should be between 1 and 10. That's what you're supposed to have. So this number between 1 and 10, we're going to move our comma. That's 1, 2 here. So now the number is 9,78. It's now between what? It's now between 1 and 10, which is 9,78 multiplied by 10 to the power of the number of commas that you moved. You said 1, 2. So it's going to be a -2. Why? We started with a 0 digit here. Whenever you start with a 0 digit, it means your exponent is going to be a negative. That's what you are going to have at the end. And let's cross-check the other part, evaluate. This is a division here. We are dividing. That's actually division. These two, they are dividing. Okay, so take note, it's not a plus there. So it's 39,6 divided by 0, this is 0,09. So as you can note, we have to get rid of the decimal places which are in the denominator, and we've got 1, 2. So we're going to multiply by 100 over 100 in this case. So multiplying by 100 simply means we are going to have how many commas? In this case, we are going to move 2 commas to the right. So it means we are going to have something like this, 2 commas to the right, that is 1, 2. So in place of this, we are going to put a 0 in that groove. So this is going to give us 3960 here. So take note, there's a 0 here. Over, we move 2 commas, which is 1, 2. So this is going to be 9,0, which is just 9. So we can divide here. 9 into 39, that's into 36, is going to be 4 times into 36. We've got a remainder of 3 into 36 again, that is 4. 9 into 0 here, that's a 0. So you're going to obtain 440 in this case. All right, so that's what you're going to have. The next part of the question is to simplify 2 over 3 minus 1 over 2 times 3 over 4, giving your answer in its lowest terms. So BODMAS, guys, remember I told you that BODMAS still exists. So which means applying our BODMAS, we've got brackets off. So you have to remove the brackets first, which is 2 over 3 minus 1 over 2. So how can we remove the brackets here? We are actually subtracting. So that means we are going to find the LCM of 3 and 2, which is 6. That is the lowest common multiple there. So 6 divided by 3, which is going to give us 2 times 2, that is 4, minus 6 divided by 2, which is 3, and 3 times 1 here, which is 3. So if you are to subtract this, you are going to obtain 1 over 6. That's 4 minus 3. which is 1 over 6. So the 1 over 6 here is from this bracket here. So you're going to have 1 over 6 now times 3 over 4. So you're done with the brackets, it's just 1 over 6. So now take note, you're into your multiplication, whereby you know that whenever you're multiplying, you can also take root, you can reduce by 3. 3 into 3, that is 1. 3 into 6, that is 2. So this part is fine. You can multiply the numerator versus the numerator, which is 1 times 1 in this case, which is 1 over 2 times 4, which is going to give us 8. So that's what you're going to have in this case from this part. Then number 3, you're given that a jet plane leaves Harare for Paria at 23 hours. That is a 24-hour notation. So this time is in 24-hour notation. The journey takes 5 hours, 33 minutes, and Paria time is 2 hours behind Harare's time. Express 23 in 12-hour notation. So the first time is to just express this. So we know that 23, guys, this is in the that is during the night hours, which is 11:23 p.m. So this is 11:23 p.m. Take note, guys, 23 is 11. If it is 00:23, then that one is 12, but 11 is 23. All right, then here we are now given on number B to find the time in Paria when the jet arrives. All right, so what is the time? So here we've got 2 options. Remember that we are given that Paria is actually 2 hours behind of Harare. So let us first take the journey. How much were the one that we have, like the time that was taken? So it's 23 plus the time that was taken. We took in this case 5 hours 33. So this is going to be 5 hours 33. But if we are to cross check, guys, the 5 hours 33 that we are going to have in this case is going to be like this: 5 hours 33. All right, this is what you're going to have actually. So if we are to add, this is going to give us a 6 here, 3 plus 3, which is 6, and this one is going to be 5, which is 56, and we add, this is going to be 28, which is 8 here, 28. So as we can see, we have exceeded our time, because we know that we are supposed to have actually the number of hours that we had is now at 28, but we know that we are supposed to have 24. So we're going to subtract 24 from this 28. All right, so it's going to be 28 56 minus, it means we have exceeded a day, and we know that we end at what? At 24 hours, which is 0, 0, 0. So if you want to subtract, use it as 24. You don't subtract as 0, 0. Okay, so you're going to subtract 24 0, 0 like that. All right, so if we subtract now the day that we have exceeded, which means we are going to have 56 here. All right, so let's just put it this way. This is 56, so we are going to have 56 minus 0, 0 there, which is 56. 8 minus 4, which is 4. 0 minus 0, which is a 0 there. So this is the time that we are going to have as a normal time when it took 5:33. But this time is the time that you are reading using the notation or the time from Harare. But now you are given that this Paria that we are talking about, the Paria, is actually 2 hours behind Harare, 2 hours behind, which means whenever you're given behind, you subtract. So we are going to subtract now 2 hours from the actual time that we have. We subtract 2 hours now. So to subtract 2 hours, that's 200 like that. So we are going to have 56 here. 04 minus 02, that is going to be 02. So that is what we are going to have in that case. So take note of the information that you are given in this case to say that whatever whatever time that you have, because in this case we are saying we're supposed to have taken these hours, but it's not like that now. It is going to arrive another time, which is actually 2 hours behind. So that is why we have to subtract the 2 hours in that case. Or we could have subtracted the 2 hours before here, because it actually came from 23 this time here, 23. We could have subtracted the 2 hours first from there, 23 23 minus 2 hours first. So we have to subtract 2 hours, which is going to be at 21. So this is actually going to be 21. All right, here, that is going to be 21, 23, if I'm not mistaken there. All right, so this is the normal time, like in Paria, this is that would be like their time. Here in Harare, it will be 23, 23, but in Paria there, it will be 21, 23. Then it took 5 hours, 33. So it's going to be 21, 33, 21, 23, sorry. So it's gonna be 21, 23 here. So let's put 23, 21, 23 plus the time that it took. Here we are told that it took 5 hours 33. So we're going to add 5 hours 33. So we are going to add 5 hours 33. All right, so if we add 5 hours 33, it's going to be 56, and this one is going to be 26. All right, so that means we have exceeded here because we've got 26. We have exceeded a day, then we can subtract that day, which is 26, 56, minus that day, which is 24, 00, like that. So we are going to have 56, 6 minus 4, which is 2, 0 there. So as you can see, we are obtaining the same answer here. So that was our answer. So this is in 24-hour notation, but in 12-hour notation, you can write this as 2.56 a.m. This is in the morning, so it's going to be a.m. This is 0256 hours or 2:56 a.m. like that. All right, so that was our time. Write down the number that we are given there as a number in base 2. So if you are given to write in base 2, remember this is an indication that you are actually converting from base 2 to what? To base 10. So the numbers that you had before here, we know that we are supposed to have the same order to the exponent of 4, to the exponent of 3. We are supposed to have to the exponent of 2 in this case, which is not there. So we have got 1 times 2 to the exponent of 4 plus 1 times 2 to the exponent of 3 plus we do not have to the exponent of 2 here. To the exponent of 2 is not there. So it means we were multiplying by 0 there. So it was supposed to be like this, 0 times 2 to the exponent of 2. That was the case. Okay, we have got to the exponent of 1, which is 1 times 2 to the exponent of 1. We know that we are left with a 0 here, and it's not there. To the exponent of 0, it's not there. So which means you were multiplying by a 0. So it was 0 times 2 to the exponent of 0. Remember, when you're converting to base 10, you start with 0, 1, 2, 3 in that order. So this 2 was not there. So it means you're multiplying by 0. This to the exponent of 0 was not there. So it means you're multiplying by 0. So these are the numbers that you had in base 2, which is 1, 1, 0, 1, and a 0 here. So these were the numbers that you had in base 2. Or you can actually convert this, write it in exact form in base 10, then you divide by 2 throughout, noting the remainders. Still, you're going to obtain the same thing. You divide the number that you're going to get, noting the remainder. So this is going to be the number that you are going to get. I don't know the number that you're going to get. You just multiply. I think it's going to be what? 16 plus 8 here. 16 times 1 is 16 plus 8 plus 2. All right, and this is going to be 10 here plus 16, which is 26. So you're going to obtain 26 in base 10. All right, then you can divide this 26 by what? By 2. We must obtain the same answer here, noting the remainder. So this is the longer way, but still it can give us the same answer. 2 into 26, that is 1, 3, remainder 0 here. 2 into 13, that is 6, remainder 1. 2 into 6, that is 3, remainder 0. 2 into 3, that is 1, remainder 1. 2 into 1, that is 0, remainder 1. So remember, your answer is taken from the bottom going upwards. So this is going to be our answer from the bottom, 1, 1, 0, 1, 0, like that. So it's going to be the same as this one, 1, 1, 0, 1, 0 in base 2. So that was this other way. But yeah, you just choose which one is best for you guys. All right. Then let's see the B part. So this was our A. Then let's move on to B. B, we are given the value of A, the value of B, the value of C. Then you're asked to simplify this as a common fraction in its lowest term. So let us substitute here C minus A. Here we are given C minus A squared. So our C is -1. So it's -1, that is our C, -1 minus A. Our A in this case is -3. So it's going to be -1 minus 3. All right, so it's -1 minus 3 like this, okay? Everything over, we move on here. So this one is B minus A. So your B is 3, all right? So your B here is 3, so it's 3 minus A. Our A is a -3. This one that we have got -3, so it's going to be minus, okay? So it's going to be minus like this. And if you are to cross-check, the whole of this bracket is being squared. So which means we are going to square the whole of this bracket. Everything that we are going to have here, we square it. So that was the consideration. So minus and a minus, guys, we know that this is a plus. So it's going to be -1 plus 3. Everything over minus and minus, which is a plus again. So it's going to be 3 plus 3. Everything to the power of 2. So you can simplify -1 plus 2. -1 plus 3, sorry, which is going to be 2. That's 3 minus 1, which is 2 over 3 plus 3, which is 6. Everything to the power of 2. So you can reduce this. All right, we can just reduce this before we proceed with our simplification. We can reduce by 2. 2 into 2, that is 1. 2 into 6, that is 3. So we're going to remain with 1 over 3 to the exponent of 2. So it's 1 to the power of 2, which is 1. 3 to the power of 2, that's 3 times 3, which is 9. Don't be mistaken, guys. 3 squared, that's 3 times 3, not 3 times 2. It's 3 times 3. So it's going to give us 1 over 9 at the end. So that's why we simply do these questions. Okay, find the cube root of 0,027. All right, so what are we going to do here? This as a fraction is simply 27 over how many decimal places? 1, 2, 3. So you've got 3 digits after the comma. So it's 27 over 1,000 as a fraction. So you simplifying the cube root of this. It's easier this way because we know that the cube root of 27, that is 3 over the cube root of 1,000. The number that multiplies itself 3 times to give us 1,000 is a 10. So that's it, guys. 3 over 10, or you can express as a decimal. 10 into 3, that is 0, 10 into 30, which is 3. So our answer is going to be 0,3. This time there's no plus or minus. This is a cube root. Square root is the one that you use as plus or minus, but cube root, we just write it like that. All right, number 5, we are given the size of each interior angle of a regular. Take note, this type of a question, guys, we've worked this so many times. It's a regular polygon and it's 168. Remember, I told you here, there are so many ways that you can find the number of sides of this polygon. And which ways? Okay, we said the first one, we can use this formula that we know that each interior angle for a regular n-sided polygon is given by n minus 2 times 180 over n. This is for each interior angle. So each interior angle is equal to this, and we are given that each interior angle is 168 degrees. So that means we can find n here by cross multiplying. That's the set of 1. So it's going to be n minus 2 times 180, which is equal to n times 168. That's 168n. All right, let's collect our like terms. Before that, let's expand the brackets. Yeah, we can expand the brackets here. So we are going to just multiply by 180 times n here. That's 180n. 180 times minus 2 here, that's minus 360, which is equal to 168n. So collect like terms. Now we can transpose this to the left-hand side. Is going to be 180n minus 168n, which is equivalent to 360. If we transpose this to the other side of the equation, it's going to be a positive. So 180 minus 68 is going to be 12n. So this is 12 here, n, which is equal to 360 degrees. Divide by 12 both sides. So which means 12 and 12 can cancel. So n is going to be equal to, if we divide this, n is going to be equal to 12 into 36. Remember, that is 3 into 0, that is 3. So it's that 0 there. So it's going to be 30 sides. So this polygon actually has got 30 sides. And that's not the only way. Remember also, this is a regular polygon. So remember I told you guys, if you are given a polygon and it's a regular, you can take advantage of exterior angles. Okay, so this is your interior angle, which is 168 degrees here, 168 degrees here. So you'll be having a polygon and so forth, and these are the exterior angles. So you can take advantage of the exterior angles. Why? Because we know exterior angle and interior angle are on a straight line. So to find the exterior angle, we are going to subtract from 180 degrees. So it's 180 degrees minus 168 degrees, because they are on a straight line, and you're going to obtain 12 degrees. So each exterior angle is equal to 12 degrees each, because it's a regular polygon. And we know that all the exterior angles, they are going to add up to 360 degrees. So if exterior angles, they add up to 360 degrees, therefore, the number of sides is going to be 360 degrees divided by each exterior angle, which is 12 degrees. So as usual, this is 3, and that's a 0 there. So which means we're going to have 30 sides. So that was it, guys. Yeah, so many ways that you can actually work out these questions and so forth. All right, number 6, we are given vector A, vector B. Express A minus B as a column vector. So this one is simply substituting A is there, which is -1, -2. That's it. Minus B, our B is already there, which is -3, -4. So that's it, guys. It's just a matter of directed numbers, where you're supposed to know that whenever you're dealing with minus, it's a plus. So it's going to be -1 plus 3, minus and minus is a plus also. So it's going to be -2 plus 4, like that. So that's it from your directed numbers. So 3 minus 1, that is 2. 4 minus 2, which is 2. So that is our vector in this case. So that's what you're going to hear from this part. And the B part, the modulus of B, guys, we know the modulus is simply the square root of x squared plus y squared. So it's going to be the square root of x here, because we are referring to B. So this is your x and this is your y there. So your x is -3. So it's going to be -3 squared plus your y in this case, which is -4 squared. So that's what you're going to have. -3 squared is simply -3 times -3, that's 9. -4 squared is -4 times -4, that's going to be a positive 16, because negative times negative is what? It's a positive. And if we add 9 plus 16, that's 25. And square root of 25, we know that it's plus or minus, but this is modulus, which is length. You're going to take the positive value, and that's units. So it's going to be 5 units. It's like length. Length is measured in basic units. So it's just going to be units like that. All right. So these are the typical questions actually that you might be given, vectors and so forth. So you have to be very, very careful with the questions that you're given there. All right. So that was it. A is a set of perfect squares less than 50. So A, these are perfect squares less than 50. B is a set of even numbers not greater than 20, which means we are talking about less than 20. That is not greater than 20. So that's what you're given. Given that A and B are the elements which are all numbers, list the elements of set A. So definitely our A, we are given that A, these are perfect squares, which are actually less than what? Less than 0. And we are referring to the whole numbers that we are going to have as perfect squares. We are going to have a perfect square, which is 1, 4, and so forth according to our syllabus. So we're going to have 1, 4, 9. Then we have got 16. We have got 25. We have got 36 here. All right, sorry, we have got 49, 7 squared, which is 49. All right, so take note, these are less than 50, so which means we are going to end up to 49, because we're supposed to have 64 and so forth and so forth. So this is our A. And number of elements in A intersection B, we have to know the set B first before we talk about these elements on this item here. So we must know what is in B. So in B, what we have, B, these are even numbers, and these even numbers, they are less than 20, which means we're talking about numbers less than, not equal to 20, but less than, which means you are referring to 2, 4, 6, 8, 10, and so forth. So it's 2, 4, 6, 8, 10, 12, 14, 16, 18. So 20 is not involved in this case. 20 is not included. All right, now let us find a intersection B first. So what do we have on the intersection of A and B? So we need the elements which are found in both A and B, such as 4 and 4. So we've got 4 here, which numbers again? 16. We've got 16 and 16. That's what we only have in this case. So this is going to be 16 in this case. So these are the elements that we are going to have, which are actually in A intersection B, but we need the number of elements. So therefore, the number of elements, how many are they? 1, 2. So we've got 2 elements in this case. All right. So that was it, guys. Number of elements and so forth. Then solve the equation there. We can simply write this as a fraction, which is over 1. So you can cross multiply. That's 1 times 3, x times this. So 1 times 3 is 3, which is equal to x is going to multiply x minus 2. That's it, guys. As you can see, it's now a matter of expanding brackets, which is x squared, x times minus 2, which is minus 2x. All right, then it's now a quadratic equation. Remember, the format of a quadratic equation is supposed to be x squared plus bx plus c is equal to 0, like that. So that means we can have this as x squared minus 2x. All right, then we transpose this 3 to the other side of the equation. Is going to be minus 3 is equal to 0, like that. Okay, so it's a matter of now solving the equation, but the advantage that we had is that the coefficient of x squared here is a 1. So which means we can take advantage of factorization, where I told you guys when the coefficient of x squared is 1 like this, you simply need 2 brackets. So I'm going to use by factorization method. So what are the factors of minus 3? So these are the part that you're going to focus with. Factors of minus 3 that we are going to add, and we are going to obtain the middle term, which is minus 2. So as we can see, we have got minus 3 and 1. If we multiply this, we get minus 3. If we add this, we get minus 2. So these are the factors that you're going to have here. X minus 3, x plus 1. So this is what you do whenever the coefficient of x squared is 1. You just put direct factorization like that. All right. So it's either one of these brackets must be equal to 0 or the other bracket must be equal to 0. So that's it. So it's either here, this bracket, let's just put it this way. This x minus 3 must be equal to 0, or x plus 1 must be equal to 0. That is now what it means at this stage. Either one of these must be equal to 0. So definitely minus 3 to this side is going to be a positive 3, or our x is going to be positive 1 to this side, which is going to be a negative 1. All right, so these are the values of x that we're going to expect from this equation that you're being asked to solve. So it's a matter of knowing the stages that you're supposed to follow and so forth. All right. B is east of A on number 9A. We are given that B is east of A. State the 3-figure bearing of A from B. So if B is east of A, it means we've got something of this nature here. Remember, it's east of A, so you start with point A. So this is where our A is located. We've got North Pole here, and this is your A. So we are given that B is east, which means we are talking about to the east of A. So we are going to draw a straight line in the east line on A. This is the east line, straight like this. All right. So that is where our B is going to be located. And we know that wherever we are going to reach, we must have a North Pole. So we are going to have a North Pole at what? At this point here. So that is what you're going to have. So this is the North Pole of point B. So we know that if it is to the, remember, this is your east, guys, here. So it means it is going through the angle of 90 degrees here. This angle is 90 degrees. And also this angle here is 90 degrees. So the question now is, what is the bearing that we are going to have of A from B, which means we are referring from this point B, and it's a 3-figure bearing, which we said is taken from the north in a clockwise direction to the line that goes to the point A. So this is the angle that we need. So as we can see, we simply need to remove this 90 degrees from 360 degrees. So if we remove this 90, we are going to remain with 270 degrees. All right, so that will be our bearing. So the bearing in this case is going to be 270 degrees. That is our 3-figure bearing. All right. That was it from this case. If we are given such type of questions, guys, that's what you are supposed to attempt them. All right, express 33 degrees, 33,55 degrees in degrees and minutes. So this is in degrees and minutes. How do you convert, guys, to degrees and minutes? Remember, the idea is that whenever you are given degrees and degrees like this is 33 degrees, 33, 55 degrees. Okay, what you do is that this is a complete indication of the number of degrees, which means we've got 33 degrees. Then we are going to remain with the 0,55 degrees. So we are separating this. So it was 33 and 0,55 degrees. So since this 0,55 is less than a degree, is less than 1 degree, it is the one that you are going to convert to minutes. So we have to convert this now to minutes. How are we going to convert this to minutes? Because your answer is needed in degrees and minutes. So remember that in a degree, we have got 60 minutes. So 1 degree is equal to 60 minutes. What about 0,55 degrees? How many minutes we have? So it's just a matter of multiplying. As you can see, this over this, that's 0,55 over 1 times 60. So that's what you're going to have. And if you multiply, that's a 0 is a placeholder here. 6 times 5, which is 30. We've got 3. 6 times 5, which is 30. 30 plus 3, which is 33. Our main decimal place 1, 2. So it's going to be 33,00, which is 33 minutes. So it means we are going to be left with 33 degrees. We converted this to minutes. It gave us 33 minutes like that. All right, so that's what you're going to have. So it's 33 degrees, 33 minutes. That was it in this case, and we are given psychogeometry, guys. And so the best for psychogeometry, try to fill in your diagram and so forth before you attempt the question, if possible, applying the laws and concepts that you're given. So in this case, take note, we have got these points which are on the circumference of a circle, and this statement, which is clear. Let me try to adjust a little bit. Maybe you can see what is happening here. All right. So there we are given that these are straight lines, PTS and the QRS, okay? So we've got PTS and QRS, these are straight lines, and PR is a diameter. So from P here to R, this is a diameter that you're given. So you know that a diameter subtends an angle of 90 degrees at the circumference. So which means this is going to be 90 degrees at T. And also this angle is going to be 90 degrees. Why? Because we said these are a straight line. So angles on a straight line add up to 180. So this is 90, this is 90. All right. And yeah, there are so many ways that we can actually have this angle here is 50. This angle also at Q is going to be 50. Why? They are subtended by the same chord, which is this chord TR. They're subtended by the same chord on the circumference in the same segment. All right. So that's what you're going to have. So let's see the first question, what you're given. Calculate item 1, PRT, that is angle PRT, PRT, P to R to T, which is this angle here. So what is going to be this angle that you're given to calculate, which is this one, that is PRT. All right, so as you can see, guys, we said this angle inside the triangle is 90 degrees. And we can just take advantage to say that our PRT is going to be angles in a triangle, which we know that angles in a triangle, they add up to 180, minus these two angles which are inside the triangle, which is 50 degrees plus 90 degrees. So that's what you're going to have. So in this case, it's going to be 180 degrees minus 50 plus 90, which is 140 degrees. All right, so if we subtract this, we are going to obtain actually 40 degrees. Okay, so this is the angle that you're going to have here, which is 40 degrees like that. All right, so that was the case actually working with angles in a triangle. But since you know that this is 90 already, you can just find this angle by simply subtracting that 50 from 90. 90 minus 50, you get 40, just like that. All right, so it can be the easiest and quickest way of doing it. Okay. QTS, that is the second part that you're asked to calculate here, which is QTS, that is QTS. So QTS, which means we are referring to the whole of this angle here. This is your QTS, this one, the whole of this angle here. This is our QTS. All right, that is the whole of this angle here, including this piece and this. Remember, I said this is 90 here. So we're going to include this piece and this 90 here that we have got here, this 90. So we're going to add this 90 and this part, this dot here. But what are we going to do? Okay, this is our question. What are we going to have in this case? All right, this is it, guys. The other part that we are given from this, remember, we can work from the codes and so forth. I want us to cross-check what we have here. If we are to cross-check from this code, we say this is actually 50 degrees, which is this angle Q is 50 degrees, okay? And this angle here is 28. Instead of using this 9, we can actually use the whole of this triangle here like this one. Here we have got T, we have got Q, we have got S here. And this angle here is 50 degrees. This angle here is 28 degrees. So we need this angle here, which is QTS, the one that has got the 90. And the 90 is already inside, but we are not focusing with this at this moment. We are calculating the whole of this angle at once. So what are we going to do? We are just going to simply subtract these two from 180 degrees. That to be our QTS. So our QTS is going to be 180 degrees minus these two angles, which is the 50, the one that we got from angles which are made by the same code, plus 28 degrees together. All right, so if we do this, it is going to be 180 degrees minus 50 plus 28, which is 78. And if we subtract, we're going to obtain something like 102 degrees. All right, so this is going to be 102 degrees. The whole of this angle is going to be 102 degrees. Okay, then C, that is QTR. So we need QTR in this case. All right, so where are we going to have our QTR from? I want us to cross-check here. That is QTR, this angle, that part here that we have got here that I'm indicating. This is our QTR, this one. All right, so the QTR, remember, it's a combination of this 90 degrees and because remember we said the whole of this angle is 102 degrees. So it means what we are just going to do in this case is to subtract this angle here, this 90 degrees. We are going to subtract this 90 from 102 in order to find this remaining angle here, because it's the one that you want to calculate, this one. So we're just going to subtract it from what? From 102, because we are given the whole of that angle. So it is going to be 102 degrees minus, we remove this 90 degrees. The moment we remove this 90 degrees here, because there's 90 degrees here, the moment we remove this 90 degrees, it means we are left with this angle here. That is the idea there. So by removing 90 degrees, that means our QTR is going to be 12 degrees. Okay, so that one is going to be 12 degrees. If you subtract properly, that's what you're going to have. So that was it, guys. It's just a matter of working with the different questions so that you can understand geometry. Actually, that's it. Solve the simultaneous equations. So it depends with the method that you're going to use. But in this case, I'm just going to take advantage of substitution, because already y is the subject here. They've already made y to be the subject of formula. So I've got my equation 1, my equation 2 in this case. All right, so what am I going to do? I'm going to substitute equation 2 into equation 1, because already y is the subject in this case. So this is going to be 3x minus, in place of y here, we are going to substitute our y, which is 5 minus x. And this is going to be equal to 7. So using substitution, yes, you can use elimination, whatever type of method that you want. But if you are to use elimination, make sure that you make arrangements properly here. So which means you are supposed to rearrange 3x minus y is equal to 7. You transpose minus x to this side is going to be positive x plus y is equal to 5. That's what you're going to do. Then you can use your elimination method. Okay, but using substitution, already y is the subject, so you substitute into equation 1 like that. Okay, so you're going to expand brackets and find x, that's minus times 5, which is minus 5, minus times minus x, which is plus x, is equal to 7. So it's 3 plus 1x. This is x, which is same as 1x. So 3 plus 1, that is 4x. Transpose your negative 5 to the side of the equation, it is going to be a positive 5 in this case. All right, so being a positive is going to be 7 plus 5, which is equal to 12. So you can divide by 4 in this case. All right. So our x is going to be 4 into 12, which is 3. So this is the value of x that we have obtained, which is 3. But already y is the subject of the formula in this case. So that means we are just going to substitute here because already we are given that y is equal to 5 minus x. So it's an advantage because we now have the value of x. So y is equal to 5 minus this x, which is 3. So it's going to be 5 minus 3, which is 2. So y is going to be 2 like that. All right. So it's actually direct. It was actually a direct question. So you prove with this method of elimination if you're going to obtain the same answer. All right, it is given that y varies directly as the square root of z. So this is the square root, not the square, but the square root of z like this. All right, so it means y here varies directly as the square root of z. That is what it means. All right, so the first part is to write down the equation connecting y, z, and take note, and a constant k. So which means we need the constant k. So you know that y is equal to k square root of z. That is introduction of the constant. You're done. And find k now when y is 3. So answer the question. This is paper 1, guys. Your item A is done like that. Okay. Item B, you need the value of k. So you're going to substitute now whatever information that you have, because the value of y is there, which is 3, is equal to z. Your z in this case is 4. Guys, today there's a lot of noise. So it's going to be square root of 4. That is your z times what? Times k. All right. So 3 is equal to the square root of 4, which is actually 2. So it's going to be 2k divide by 2, divide by 2. So in this case, our k is going to be 3 over 2. That is our value of k. So you are done. You can write it as a decimal, as a fraction, as a mixed fraction, but this is your value of k like that. You're done. So that was it. Then on C, you are now asked to calculate the value of z, or to find the value of y. Find y when z is 16. So what you are going to do, you have this equation first, whereby you're going to substitute the value of k here, because you have got the value of k. So y is equal to our k. Remember, your k is 3 over 2. So it's going to be 3 over 2 square root of z. All right, so now you can substitute. Since you want the value of y is going to be equal to 3 over 2 times the square root of z, which is your z is 16. So it's going to be square root of 16. All right, so let's simplify, which means our y is going to be equal to 3 over 2 multiplied by square root of 16. Of which you know that square root of any number is plus or minus, but when you are working with this type of equation, when you are inside the equation like that, we just use the positive value, which is in this case is 4. So it's 2 into 4, which is 2. 2 times 3, which is 6. So this is the value of y, which is going to give us a 6. So that was it for this particular section. So let us see number 13. Number 13, we are given a triangle, which is a right angle triangle that we are given A, B, C, D. And the triangle is a right angle at C, which means we've got 90 degrees here. The angles are 45. Guys, if this is 45, definitely this is going to be 45. Remember, 90 minus 45, this is going to be 45 degrees, which means this triangle is actually an isosceles triangle. From B to C is the same as D to C. That is what it means. Okay, then we are given A, B, C is a straight line, so which means these are angles on a straight line. Then use the information to calculate CD. So the first part is to calculate this distance from C to D. Okay, so as you can see from this smaller triangle BDC, there's nothing that we can use because we are just given angles only. We are not given any side. So it's going to be difficult for us to work with this because even of the information that we have. All right, so I'm going to take the bigger triangle from A to D to C, this bigger triangle there. That is one that I'm going to take from A to D, then to C like that, so that we can calculate our DC. This is your D, this is your C, this is your A. So this angle, we know that is 30 degrees at A, and we are given AD, which is 6. This is 6, and you want to calculate D. So at least like this, we can calculate this DC because we know that this is at 90 degrees. So let's just put this as X, or you can just whatever that you're going to write. which means according to this angle of, as you can see here, definitely you have to work with trig ratios because we are given an angle here. So this is your opposite and this is your hypotenuse. So which ratio uses opposite and hypotenuse at the same time? So we are now going back to your soccer tower there. So we know that from our soccer tower, the one that has got opposite and hypotenuse at the same time is the sine, where we know that sine theta is equal to opposite over hypotenuse. So we can play around this because we've got the theta in this case, which is 30 degrees. So sine 30 is equal to the opposite, which is the one that you want to calculate, which is this DC. So it's going to be DC, or it's what, CD? It was CD or DC, whatever that you're going to have. Let's see. Okay, it's given a CD. So let us just write the way that they gave us, but that is actually one and the same thing. All right, but just that we are given a CD. So let us just write it as the way that we are given over the hypotenuse, which is in this case, it's 6. So it's going to be 6. All right, this is same as over 1. So you can actually cross multiply in this case to find what? To find the value of CD, cross multiply this side, cross multiply this side. So it's 1 times CD, which is CD is equal to 6 times sine 30. So it's going to be 6 sine 30 degrees. All right, now simplifying further, we have got the value of sine 30. Do we have it from this information? We have got sine 30 as 0.50. This is same as 0.5. The 0 after the comma does not even matter. All right, so our CD is going to be 6 times 0.5. 0.5 simply means half, guys, or you can multiply 6 times 5, which is 30. Our main decimal place, we just have 1 decimal place. So it's 3.0, which is 3 centimeters. All right, that is your CD in this case. So we managed to obtain this as 3 centimeters. But let's come back to our diagram because there's something that we said. We say this CD or DC is the same as BC. So if this is 3 centimeters, it means also this is 3 centimeters. All right, that is what actually it means. All right, then the other question now is to calculate A, B, giving your answer correct to 1 decimal place. Okay, that is A, B, from A to B. So as you can see, A to B is this distance here. This is your AB. And if you are to cross-check, we have the whole, we do not have this AC, sorry, but we can find this AC from this diagram here. This is your A to C. So which means we can use that bigger triangle to find AC, which is this one, since we have got BC. So it means for you now to have AB, your AB is going to be equal to the whole of the line, which is AC. It's going to be AC minus BC. So you're going to subtract BC because you already know from that concept of isosceles triangle that I mentioned before. So how can we calculate BC? Let us cross-check on our diagram. What are we given this time? Let me just try to remove 1 or 2 here. So we are no longer working with this. We are now working with what? Yes, we can use the 3 because the CD, we obtained it. So here I can even substitute that side because I've already calculated this side. This is now 3. All right, so we want to calculate this side, DC. So it depends with which one are you going to use. Are you going to use the 6 or the 3? Working with the 6 here, this is your, according to 30 degrees, working with this 6 here. This is hypotenuse, does not change, and this is your adjacent. All right, so it's best for you to use it because these 3, you are the one who calculated it, remember. So if you make a mistake, which means you are going to make a mistake also here because you are using a wrong value, but actually our value is fine, so you could have just used it, but I'm just saying in exam condition. Okay, so it is cos, and we said the ratio for cos here, if we are to cross-check our ratio for cos, is adjacent over hypotenuse. So which means we shall have our cos theta, which is equal to adjacent over hypotenuse. All right, so let's go back here. Our cos theta, which is the angle 30 degrees, so it's going to be cos 30 degrees. So we've got cos 30 degrees, which is equal to the adjacent, which is the side that we have to calculate, which is this AC. Remember, we said we need AC here. So it's going to be AC, that is your adjacent, over the hypotenuse, and the hypotenuse does not change, which is our hypotenuse is what? Is still 6. All right, so our hypotenuse here is a 6. So to find AC, definitely we need to cross multiply in this case so that we can have our AC. So we're going to cross multiply here, cross multiply there. So which means we shall have something of this nature. 1 times AC, that is AC is equal to 6 times cos 30, that is 6 cos of 30 degrees. All right, so this is where now we are going to take the information that you are given. Cos 30, we now have this cos 30 here, it's 0.87. So you're going to multiply by 0.87. All right, so if you multiply by 0.87, we are going to obtain something like 5.22, if I'm not mistaken, which is 5.22 centimeters as our AC. Now let us get back here because we want to find AB. Remember, guys, we just obtained AC. So let us get back here. We said AB, the one that we want to calculate, is going to be AC. The one that we got now, which is AC, is 5.22. All right, so it's going to be 5.22 minus BC. And this is our BC here, which is 3. All right, so if we subtract, this is just 5.22 like this, guys. 5.22 minus 3.00 as a whole number. So it's going to be comma here, 22. 5 minus 3, which is 2. So you're going to have something like 2.22. But there is something that you are given, correct to 1 decimal place. Your answer is needed to 1 decimal place. And how many decimal places do we have on our answer? We have 2 decimal places. So to 1 decimal place is going to be 2, this 2 is 1. So this 2 cannot round off this 2. So it's going to be 2.2 centimeters. All right, so that is our final AB, which is 2.2 centimeters in this case. All right, so that's 2.2 like that. So that's what we had this case, just like that. Simplify on number 14, we are given 2a to the exponent of minus 2 times out. So this one, all we just need is to expand the brackets. We know that each and every term is going to be raised to the exponent of 2. We can do that. We can just, it depends with how you want to apply it, but I'm just going to raise everything to the exponent of 2. So it's going to be 2 to the exponent of minus 2, and this a to the exponent of minus 2. So it's a to the exponent of minus 2 times 3a to the exponent of 2. All right, knowing that any number to the exponent of a negative simply means 1 over. So 2 to the exponent of minus 2 means 1 over 2 to the exponent of 2, and that is 1 over 4. So this here means we have got 1 over 4 a to the exponent of minus 2 times 3a to the exponent of 2. So we can now multiply these numbers direct. So it's 1 over 4 times 3, which is 3 over 4. All right, now let us get to the a that we are given here. This a is multiplying to this a. We know that when you're multiplying, we add the exponents or the powers. So we're going to add minus 2 and 2. That's a 0 here. So it's going to be a to the exponent of 0, which is a 1. Any number to the exponent of 0 is 1. So this one is simply being multiplied to 1, and multiplying to 1 does not change anything. So it's just going to remain as 3 over 4. So that was the case in this case, all right? On B, we are asked to evaluate or to simplify. This is log 8, which is being divided to log 4. So log 8 divided by log 4 can be written like this, log 8 over log 4. So one and the same thing, where, guys, we can use the law, or we can convert these to basic numbers that are the same, 4 and 8, which numbers that we can use in this case so that the 4 and 8 must be the same. 4 and 8, these two numbers, they must be same. So 8 is same as 2 to the exponent of 3, which is 2 to the power of 3. 4 is same as 2 to the power of 2. All right, that is our 4 in this case, which is 2 to the power of 2. So we can actually remove the exponents by dropping these exponents from our laws of logarithm. So you can drop this, which is 3 log 2. So it's going to be 3 log 2 over. If we drop this exponent here, it's going to be 2 log 2. So this was going to give us 2 log 2. So definitely the logarithms are the same. So we can cancel out these logarithms, the log 2 and the log 2 together. So if we are to cancel this, that means we are going to be left with the 3/2, which is just 1.5 or 1,5, or no matter the way that you're going to write it, or you can just leave it like that as 3/2. You'll be done actually. All right, so that's what we had, guys. And move on to number 15, where we are given matrices. Find in terms of X the determinant of A. So determinant, guys, we know that is the product of the major diagonal minus the product of minor diagonal. So which is A, B, C, and D. And we say that determinant of A is given by AD minus what? Minus BC. So this is A times D, which is -1 times X minus 1. So you multiply the bracket of X minus 1 minus BC, B times C, which is 2 into X plus 1. So this is the expression for determinant. Then let us multiply, expand brackets, -1 times X, which is minus X. Remember, this is needed in simplest form. That's why we have to expand brackets. -1 and -1, that's a +1. -2 times X, that's -2X. -2 times 1, which is -2. Then collect like terms, we've got -1X, -2X. So -1, -2, that is -3 from our directed numbers. 1 minus 2, which is -1. So that was the expression for the determinant. So this one is just an expression. Yes, you can factor out minus, it's fine, or you can just leave it like that. You need the expression for determinant, just like that, you're done. All right. Then B, find BA, that is B times A. So this is your matrix B, which is 3, 4, multiplied by matrix A. This is your matrix A, which is X minus 1, 2, X plus 1 and -1. So remember, your matrix multiplication is row by what? Row by column. So it's going to be this row and this column. That's 3 into X minus 1 plus 4 multiplied by X plus 1. So remember, we are still having numbers in the row. That is why we have to add. We are done with this row and this column. So we move on to this row and this column now. So it's 3 and 2. So it's 3 times 2, which is 6, plus 4 times -1, and 4 times -1 is -4. So that's what you're going to have. And as an expression for the determinant, as an expression for the product, sorry, of the two matrices. And also the order is very important that you know your final answer. Remember here, you're multiplying 1 by 2 matrix to a 2 by 2 matrix. So your answer is going to be a 1 by 2 matrix. That's you're going to have a 1 by 2. All right, so it actually helps you to just know what your answer is going to be like. Okay, so let's just expand brackets and simplify. 3 times X, that is 3X. 3 times -1, that is -3. 4 times X, that is going to be plus 4X. 4 times 1, which is going to be plus 4. All right, so this is just a single part, but put in a bracket. All right, then we move on here, plus and minus. That's a minus, so it's going to be 6 minus 4, which is going to be 2. Okay, that's 6 minus 4, which is 2. So this part is just going to give us 2 here. All right, then let's simplify this part with brackets. 3x plus 4x, collect like terms. So it's going to give us 7x. Minus 3 plus 4 is simply 4 minus 3, which is 1. So it's going to be plus 1. So remember, this is a single term. You're just going to put it in a bracket like that. So that is it. So as you can see, guys, this is a 2 by 1 matrix. We've got, it's a 1 by 2. We've got 1 row and 2 columns. So it matches the answer that we are supposed to have here. So that was it, guys. As you can see, it does actually direct the questions. We just direct like that. All right. Then number 16, on one day, the exchange rate was 9 Rand. 0.03. A trader exchanged $600 for rands. Find the amount in rands the trader received. So we need the amount in rands in this case. Okay. So each US dollar is equated to what? Is equated to 9,03 Rand. All right. So this is 9,03 Rand. And what about 600 US dollars? So 600 US dollars for that particular month, or for that particular transaction is going to be 600 over 1. Remember what you need here over what you are given. So 600 over 1 times 9,03. So multiply properly here, that's 0, 0, 0. So you're going to have 0, 0. 6 times 3 That is 18 carry 1, 6 times 0 here, that's 0 plus 1, which is 1. Then 6 times 9, which is in this case, it's 54. All right, if I'm not mistaken, that's 54 there. How many decimal places? 1, 2. So it's going to be 1, 2, which is comma here. All right, so this is the amount that you are going to have in rands, which is 5, 4, 1, 8 rands, or you can put comma 0, 0 if you want, because this is money, or just leave it like that. It's still one and the same thing, or it's still fine. There's no effect. All right. Given that f is equivalent to all this expression, express m in terms of this, so we simply make m to be the subject. This is same as over 1, so cross multiply to remove fractions. F times t, that is ft, is equal to mv, so 1 times this is going to be mv minus mu if you multiply by 1. Since we want to make m the subject, we can see that m is common here, so we can factor that m which is common, which is v minus u, which is equal to ft. All right, since I want to make m to be the subject, I can divide by this bracket, which is common, which is the bracket here that is affecting by multiplying. So I'm going to reduce by dividing it. So therefore, I'm left with m, which is equal to ft. So this is going to be ft over v minus u. All right, so that's what you're going to have as our m. So therefore, our m is going to be ft over v minus u. Just like that, guys, we are done. All right, so as you can see, this question will be actually be direct, as you can see. All right, then this question is a velocity. I don't know how we are going to, I don't have a ruler here. Okay, I'm just going to see what we are going to do so that you can actually understand what's happening. An object starts from rest, accelerates at 4 meters per square second for 5 seconds until it reaches a speed of 20. All right, so actually we are drawing. So for us to draw the first part, guys, we have to move stage by stage. Okay, so the object started at what? Started from rest, accelerates for 4 meters for 5 seconds until it reaches 20 meters per second. Okay, remember acceleration, guys. You started from rest. This is your velocity time graph, where we are given this at 0 here. So this is actually at 0 at rest. You are at 0 here, that is at rest. So this is where you started, and it accelerated to which velocity? Can we just get back here to a velocity of what? Of 20 meters per second in 5 seconds, for 5 seconds. Okay, so it's 5 here for 5 seconds versus 20, which is your velocity. So you mark where there is 5 versus 20. So 5 versus 20 is this point. You mark that point. Okay, so this is actually acceleration, which means you are increasing from this point, guys. I don't know if I'm going to draw something nicer here. I want to reach this point. All right, so you're supposed to use your ruler, guys. All right, you're supposed to use your ruler here and something of that nature. Okay, so that is from 0 to this ruler. So this is supposed to be a straight line using your ruler. Okay, but in this case, I do not have. I'm just going to, this application does not have ruler. So guys, I don't know, but I hope you understand. Then it then travels at this speed for 30 seconds. Okay, so this is the speed of 20 that we are given. We are at 5 seconds. Remember, we're at 5. So if we add 30 seconds to 5, it's going to be 30 plus 5, which means we are going to end up at 35 seconds. We are going to end up at this point at 35 seconds, still maintaining the same speed, which is at what? At 20. So here we're just going to draw a straight, because we are maintaining this distance. So draw a straight line along that 20 there. You draw a straight line straight up to this point, which corresponds at what? At 30. We have exceeded, guys. 35 is actually somewhere here. All right, so we have exceeded. All right, let me see if it is going to erase properly. This eraser, that's why. Okay, it's now okay. I think it's fine. So it's actually this point here. That's where we are supposed to end. So this time you can just indicate with the dotted lines, even on that part. Okay, I'm going to show you like this. It corresponds with 35, so it must be at 35. Even at this point, you can just indicate with dotted lines to show that this point here corresponds with what? It corresponds with 5. Okay, so that was at 5 like that. So we are now at this point versus 35. So we are now at 35, still at this velocity of 20. We are still under the velocity of 20. Okay, then what happened? If you have to cross check there, and after, now it's a comma here, after, which means it's another step, which it decelerates. Remember, decelerates, you're now going down uniformly and comes to rest after a further 10 seconds. Okay, so it's going to go down to rest in 10 seconds. Remember, we are at 35. So if we add 10 seconds to 35, which means we are going to be at what? At 45 seconds, but now at 0. So it means here your velocity is at 0 here, but you are now at 45. So you're going to join from this point until you reach what? At 0. So that's it, guys, until we reach a 0 here to this point. All right, so that was your velocity time graph. So that's the major points here: 0, 5, 35, and 45. So these were the major points, and this one at 20. Those are the points which are supposed to be clearly indicated on your diagram, and you join using a ruler. That was it. Then after drawing the velocity time graph, the question is now to calculate the total distance traveled. All right. So what are you going to do to find the total distance traveled? As we can see, guys, we remember total distance is actually area under the graph. So you can choose to work with the triangle, a right angle triangle, a rectangle, and a triangle, which means you are going to divide your graph into 3 shapes, which means you work area of a triangle, a rectangle, it's up to you, or you can just use this area at once. As we can see, the whole shape here is a trapezium. So I'm just going to use that one of a trapezium, because we know that area of a trapezium is half sum of parallel sides times the perpendicular height. So that's what I'm going to use, the shorter one. So in this case, my parallel sides, let me indicate back here. These are the parallel sides, the side that will never meet, which means we are referring to this side and this side. So we need the distance or the corresponding value from this point here and this point here. So remember, this is 5 and this is 35. So 35 minus 5, which means we have got 30 here. All right. And the other parallel line is actually the whole of this line from 0 here up to what? Up to 45 there. So that's what you're going to have, that up to 45. So it's going to be 30 plus 45. So this is 30 plus 45 here. All right. So it's going to be half of 30 plus 45. All right, so that's what you're going to have, multiply by the height. So the height now is this distance that we have from our diagram, this distance, the whole of this line here, that's your height, which is in this case corresponds with 20 there. That is your height. So you multiply by 20. All right, so that's what you're going to have in this case, which is a 20 here. So adding these two is going to be 30 plus 45, which is something like 75 here. So you're going to obtain 75 if we add this, and half of 20 here is 10. And if you multiply 75 times 10, it's going to be 750 meters. All right, so that was going to be the distance that was traveled in this case. Here it was going to be 750 meters, the whole distance under the graph. All right, so that's it, guys. You just write your answer where it's supposed to be written, 750 meters. Already the units are already given. All right, so that was it, guys, for distance. So like I said, you can use those triangles. So I want you to try to work with the triangle and the rectangle and this triangle and see if you're going to obtain the same answer, just like what we got here. All right. Number 18, we are given number 18, 9 white and 6 yellow identical tennis balls are placed in a box. Kuda picks balls at random, one at a time. Find the probability that the first and the second balls picked are both white of different. Okay, so this is actually probability where we are going to apply tree diagram. Remember, this is when you give it a condition like this, you actually work without what? Without replacement. Without replacement. So that's what you're going to to have in this case. So meaning to say we need our tree diagram. We are working with two branches, white and yellow in this case. All right, so this is what you're going to have. You're going to have a branch of white and yellow. All right, so these are the two branches that you're going to have, white here and yellow. So this is actually your first pick or your first choice. Then we pick the second one. The second one in this case, so this white is going to branch again, giving us white and yellow. So it's white, yellow here, white, yellow here. So this is white and yellow. All right, so now from this concept, remember guys, without replacement, make sure that you watch the video that I made on probability. Yeah, you can understand this much better. All right, so the first part, how many white do we have? We have got 9, which are white in this case. So white is 9. Out of the total, you add these two, 9 plus what? 6. So if we add, we are going to obtain 15. All right, so this is going to be 9 out of 15. All right, but take note, you are working with white in this branch. So if you have picked a white, which means the white on the second pick here is going to reduce. There were 9 of them, now there are 8 because you have picked one white. So you're going to remain with 8 white out of 14. So the white is the total is going to be affected, is now out of 14. And the yellow, they are still the same as they were, which is 6 out of what? Which is 6, but the total is now affected. Remember that, 6 now out of 14. Then we move on to this branch of yellow. The yellow, originally, there are 6 out of 15 in this box that we have. Is it a box or it's what? Okay, in a box, exactly. Now, we pick another yellow. So you continue with this yellow, then you pick another yellow. So there were 6, now they are going to be 5. So it's 5 out of the total also is affected. So it's now 5 out of 14. And the white, you are assuming as if you never picked the white. So the white is going to remain as it is as before, which is 9. But the total is the one that is now affected. It's now out of what? It's now out of 14. So that is what you're going to have. And these are the outcomes from your probability tree diagram. We know that we are going to have our outcomes. In this case, it's white, white. So it's going to be white, white. And this is white, yellow. So this is going to be white, yellow, yellow, followed by white. So this is going to be yellow, white, yellow, yellow. So this is going to be yellow, yellow, like that. So these are your outcomes that you're going to have in this case. All right. Now, the question is, where are we going to have the outcomes that are both white? So we need where we have got both white, and as you can cross-check, both white is here. We've got W and W here. That's where we've got what? Both white. We do not have any other white. So probability of picking both white is going to be white, white. So that's what you're going to have. So this white, white simply means you multiply the first white was what? 9 out of 15. So that was your first white, 9 out of 15 times the second white in that branch. This is your second white, which was 8 out of 14. So if it was with replacement, it remains as it was. It remains as 9 out of 15, but this you are treating as without replacement. All right, so you can actually reduce your values so that you can simplify by 3 here, that is 3. By 3 here, it's 5. By 2 here is 4. By 2 here it's 7. Do you have anything that we can reduce? We do not have, so you can multiply 3 times 4, which is actually 12 over 5 times 7, which is 35. So it's going to be 12 over 35, just like that. All right, then we move on to the other part that we are given, which is in this case, to find the probability that are of different colors. So which one do we have that are of different colors? So different colors, which means we are talking about this region, which has got white, yellow, and this one, which has got yellow, white. That is where we have got different colors. So we are going to add these two probabilities. So it's going to be the probability of what? White, yellow. The first one plus another one, which has got different colors. It's yellow, white. So this one is going to be yellow, white. All right. So let's start with white, yellow. That is white, yellow. This one, as we can trace this, if you are to trace this branch here that is got yellow, white, it moves through this branch of white, following this route like this to yellow like this. So this is the route that gave us white, yellow. So you trace those values. There is 9/15 and 6/14. So you multiply those two. 9/15. So it's going to be 9/15 multiplied by 6/14. So this is 6/14 here, plus we move on to yellow, white. So you have to trace this path with the yellow going to white, yellow going to white like that. All right, so this is your yellow, your white. So it's going to be 6/15, first yellow, 6/15 times the white here, which is 9/14. So if you are to cross-check actually under example, you see that these two are the same. So it's simply finding one probability, then you multiply by 2. It's easier like that. Oh, that is it. Oh, anyways, let us reduce and see what you're going to have. In this case, we can reduce these values and add them. That is by 3 here, which is 3, by 3, which is 5, by 2 here, which is 3, by 2, which is 7. So 3 times 3, that is 9/5 times 7, which is 35. So this is going to be 35 plus, can reduce also here by 3. That is going to be 2 here, by 3, which is 5. All right, by 2 here, which is 1, by 2 here, which is 7. So it's 9 times 1, which is 9/5 times 7, which is 35. All right, so that's what you're going to have in this case. So if we add 9 plus 9 is going to give us 18/35. Remember, the denominators are the same, so you just add the numerators. 9 plus 9, that's 18/35, just like that. So these are the typical questions, guys. As you can see, it's very easier if you work with many questions. Yeah, if you work with many questions, it's going to be much easier, but that's what we're given in this case. So take note of the questions and how to attempt those typical questions. Something is very important there. All right, number 19, we are given in the diagram OABC is a sector of a circle, center O, where we are given the radius, which is 3.5, like that. That's our sector. And the first question is to state the name of the given shaded segment, shaded region. I'm actually saying the answer. Okay, so this is a segment here. That's a segment, but because it's subtended by 90 degrees, which is the smaller angle, so it's going to be a minor segment. That's a minor segment, so it's actually a segment. All right, so that is the shaded region. Okay, it's from a sector. All right, then the B part is to calculate the area of the shaded region. That is B, calculate the area of the shaded region. So as you can see, guys, the shaded region here, this is the shaded region that we have got. So it's actually from the area of the sector minus area of what? Area of a triangle. That's what you're going to have. So in this case, it's going to be area of sector, area of sector, that is area of a sector in this case, minus area of a triangle. That's it. So area of a sector minus area of a triangle, where we know that the area of a sector is given by this formula, remember, is theta over 360 times pi r squared minus the area of a triangle. What type of a triangle do we have? This this triangle, which is the part that is not shaded here. It's a right angle triangle because we've got 90 degrees here. So we're going to use half base times what? Half base times perpendicular height, which is half BH. All right, so the theta is the 90 degrees, which is this part here. Your angle is 90 degrees. But as you can see, guys, theta over 360, 90 over 3 is a quarter of what? Of a sector. Whenever you are given an angle of 90 degrees, it means that's a quarter of a sector, 1/4 of a circle, sorry. So it's going to be 1/4 of a circle, or just substitute 90 over 360, but still if you reduce, it's going to be a quarter, which is 1/4 times pi. Let's see our pi, we are given, always use the given pi. So take pi to be 22/7. So your pi in this case is 22/7 times r squared, which is your radius squared. So your radius in this case is 3.5, of which 3.5 is same as 7/2. If you multiply here, 6 plus 1, which is 7/2, or you can just write it as a fraction or as a decimal. Depending with the part that you're going to have. in that case. All right, but this was going to give us 7/2 as a fraction, as an improper fraction, 7/2. So I'm just going to use 7/2. Like I said, you write the way that you want. Okay, so this is your radius squared. So it's 7/2 squared, and 7/2 squared means 7/2 times 7/2. So this is actually the area of the sector minus the area of the triangle, which is half base times perpendicular height. So it's going to be half of the base, which is this triangle. As you can see from our triangle that we have got here, the base and the height are actually the same, the 7/2 and the 7/2. So it's actually one and the same thing. So it's going to be half of 7/2 times 7/2. All right, so that's what you're going to have in this case. So you play around your values, reduce as much as you can until you obtain the exact value. So the 7 and the 7 can cancel. 2 here, which is 1, 2 here, that is 11. So I think that's it, we are done. So you can multiply 11 times 7, which is 77 over 4 times 2, which is 8, minus 1 times 7 times 7. That's just 7 times 7, which is 49 over 2 times 2, that is 4, 4 times 2, which is 8. So as we can see, the denominators are the same. We can simply subtract our numerators, that's 77 minus 49 in this case, which is going to give us something like 28. I'm not mistaken here, 28 over 8. And if we are to divide by 8, it's going to be, okay, we can reduce, guys. Let us just reduce together by 4. We can reduce by 4, not by 4. Yeah, by 4 is actually fine. By 4, yes, 2. Yeah, by 4, it's going to be 7. Yeah, so it's going to be 7/2. And 2 into 7, that is 3, remainder 1, comma, into 10, which is 5. So it's going to be 3,5 square centimeters. This is area measured in square units. So that was it, guys. Area of the segment is simply area of the whole sector. You work with the whole sector, then you remove the triangle from that. You are left with what? With a segment. So that is how you calculate the area of the segment. So that is it, guys, from this part. And number 19, in a rural district, council increases the value of land by 5%. Every year is increasing 5%, 5%. If the value of the land is 5,600, what is the value in 2 years' time? So if it's an increase of 5%, guys, each and every year, so what is going to be the value after 5 years' time? So actually, this is a compound interest that you are going to have at the end, because like it's an increase, or you can calculate the amount of the first part, then you calculate the one of the next one, and so forth and so forth and so forth and so forth. Okay, because this is actually an increase of 5%. Okay, so this is what you're going to have. We know that actually for the first year, our amount was going to be equal to the principal. If you use like simple interest, it's going to be I plus IN, which is the number of years, like that. So where this is the interest. So this is the amount for the first year. Okay, so we are going to have the first year, 4,600 multiplied by 1 plus the interest. In this case, your interest as a percentage decimal, which is 5 over 100, which is going to give us 0,05. So this is 0,05. So we're going to have 0,05 here times the number of years. So this is the first year that we are doing. Okay, so the first year is just like that. All right. So which means we are going to have 4,600 multiplied by 1 times this is just 1, it's just 0,05 plus 1, which is 1,05. Okay, so what are you going to obtain if you multiply 4,600 times 1,05? So guys, I want you to multiply properly. Then you are going to obtain something like 4,830. All right, that's the amount. But this is for the first year. Then it increases again. So this is now your new principal now, which is 4,830 plus again the interest that you are given, the interest which is the 0,05 times 1, because it's now for the other year. So it's going to be the same like what we obtained. So it's 4,830 multiplied by 1,05. All right, so it's now 430 this time. This one is now 430 times 0.05. So if we multiply this by 1.05, yeah, we are going to obtain something like 507 and so forth. 507, 1.5, something like that. Okay, the 0 now, because this is amount, so you just put 2 decimal places after the comma. So this is going to be the amount now after 2 years. So it was a combination of simple interest for the first year, simple interest for another year. But we could have just done this in a simpler way by just applying our compound interest formula, because this is happening yearly, so you can use our compound interest at once, which is amount is equivalent to principal into 1 plus I to the exponent of n. That is your compound interest formula, where A is the amount after the 2 years. So the P is the principal, and our principal value in this case is 4,600. So you're going to have 4,600 here. That is 4,600 into 1 plus the interest rate. This is your interest rate, which can be written as R over 100. Still one and the same thing, because you are still going to divide by 100. And when you divide it by 100, we obtain 0.05. So this is going to be 0.05 like this, where n now is the number of years. You take all these years that are given, which is the 2 years. So it's going to be to the exponent of 2, just like that. All right. So which means this is going to give us 4,600 into 1.05 to the exponent of 2. So guys, you have to multiply these 2 times. 1.05 multiplied by 1.05. You get the answer here. Then you multiply it to 4,600. So if you get the answer, it is going to be something of this nature, 1.1025. This is what I got here. And if I multiply these two, I got something like 5071.50, sorry. So that's what I'm going to have in this case as my amount after 2 years. So as you can see, we are obtaining the same values, but this one seems to be easier as you are working with, like you are doing it stage by stage, but it's simply one and the same thing. You can just calculate it at once, depending with how you want to express your answers or how you want to evaluate it. All right, number 21, you asked to simplify. This is actually a division. We are dividing these fractions. So before you move on, let us factorize x squared minus y squared. Difference of 2 squares. This is the definition of your difference of 2 squares. We must supposed to know that, which is x plus y into x minus y. All right, from our difference of 2 squares in this case, so it's going to be x minus y in this case. All right, so this is minus y here. Everything over x squared plus xy. X is common here, so you can factor out x, and that's x squared divided by x, which is x. Xy divided by x, which is plus y, like this. Okay, we are still dividing because we are still factorizing. So we have division. 2 is common here, so factor out 2. You're going to be left with y minus x. Okay, everything over xy. So that's what you're going to have in this case. So if you have to simplify further, we are going to introduce now the multiplication here. So that means everything is going to remain as it is, but the moment you introduce multiplication, this fraction is going to invert. So which means we are going to have x plus y here into x minus y, like this, everything over x into x plus y. All right, so that's what you're going to have. Multiply by, the moment you multiply now, that's where you're saying going to interchange. So it's going to be xy over this bracket, which is 2 into y minus x. So this is y minus x, like that. Okay, so let us try to multiply whatever that we can cancel here, x plus y and x plus y. X and x can cancel. As long as it is numerator and the denominator, you can cancel. So that's what you're going to have. But cross-checking here, these two could have cancelled, but they are not the same. This is x minus y. This is y minus x. So remember, guys, I told you, for you to cancel this, you are going to introduce a negative. The moment you introduce a negative here, or you factor out a negative here, these two brackets will be the same. This will be y minus x. Multiply by this y that is here. Everything over this part that is in the denominator, you got 2 into y minus x. So the moment you introduce a negative, or you factor out a negative, the brackets that are familiar to each other, they will actually be the same. So now you can cancel them, and that means our answer is going to be what? Is going to be minus times y here, which is minus y over 2. So that's it, because this is cancelled, so it's just going to be minus y over 2, just like that. We have nothing that is left, so it's just going to be like that. All right, so that was it for this question. As you can see, guys, it was actually clear. All right, solve the equation here. What are you going to do? Expand brackets, multiply by a negative here. So it's going to be 3. I'm just going to solve it here. So it's going to be 3 minus times 2n, that's negative 2n. And negative times negative 5, which is going to be a plus 5, is equal to 32. Okay, so let us collect like terms. 3 plus 5, which is 8, minus 2n, which is equal to 32. So you want to solve for n, so you can transpose. I don't know how you are going to transpose, but you can just remain with minus 2n here. Transpose 8 to this side is going to be a minus 8, is going to be a negative 8. Since it was a plus, so it's going to be a negative 8. And if we are to subtract this, we are going to obtain something like 24. So this is going to give us a 24. Divide by negative 2, divide by negative 2 like this. So which means our n is going to be negative 12. So that's what you're going to obtain in this case. Yeah, our n is minus 12. That's it. Done on this one. So express on B now as a single fraction. So there, guys, let us just find our LCM, which is the LCD or the LCM, depending on the way that you want to have it. And 5 and 6, that is a 30 there. All right, so you have to divide 30, divide by 5, which is 6, into 7x plus 2, which is your numerator. You multiply everything. Minus 30 divided by 6, which is 5. So it's 5, open bracket. That's going to be 5x plus 3, like that. All right, so let's expand brackets, guys. 6 and 7, that will be 42x, if I'm not mistaken here. Then 6 and 2, which is 12. All right, then minus 5 times 5, which is minus 25x. All right, then minus 5 and 3, which is minus 15. All right, everything over a 30. So as we can see, guys, there we just need to, we have to collect like terms if we're possible. This is a 30 here. So let us just collect the like terms, which means we are referring to terms such as 42x and 25x. So if we subtract these two, what are you going to have? 42 minus 25, which is going to give us something of this nature, that is 17. 42 minus 25, that is 17x. All right. Then we move on to the other like terms, which is 12 and minus 15. So 12 minus 15 is same as 15 minus 3, with 15 minus 12, which is 3. Then we take the sign of the bigger number, so it's minus 3 over 30. So can we reduce this? No, we can't. So just leave it like that. We do not have like terms. We do not have this, so just leave it like that. All right. So you're gonna leave it like that, just like that. All right. So that was it there. And we are given this graph, guys. It's not even accurate. It's not like clear. Write down the coordinates of the image of P. If P is translated by vector minus 1, 4. So what is the coordinates of the, okay, the image of P translated? Okay, so let us locate our point P. This is our point P here. So the point P is actually at 1, 1, 2, 3, 4, 5. This is 1, because our scale is 1, 2, 3, 4, 5, and so forth. So this point at P here, the coordinate P, X is 1, and Y is actually minus 2. So the point is 1 minus 2. So you can actually use the translation vector to find the image. Remember, image translation vector is equal to image minus object. So I'm just going to write it like this: image minus object. So I want to find the image. I can transpose the object here. So translation vector plus the object should give us the image point. So which means the image is going to be, the translation vector is there, which is minus 1, 4. So it's minus 1, 4 like this, plus the point P, which is the object here, which is the object that was there before, which is P. And we said P, it's 1 minus 2. So you're going to substitute that which is 1 minus 2. So if we add, that will be your image. So minus 1 plus 1, that's a 0. 4 plus minus 2 simply means 4 minus 2, which is 2. So this is your image P. As the coordinates, now you write it as 0, what? 0, 2. This is a vector, then you write it as coordinates now as 0, 2. So that's what they actually needed. Or vector, you can simply move. This vector is actually a movement, X and Y. So in the X, we moved 1 unit to the left, then 4 units going upwards. So it's minus 1, then 4 units going upwards. So let us try to see if we are going to obtain this same answer here. Let us move from the graph. Okay, so this is our P here. So we're going to move 1 unit to the left, which is 1 unit, which means we are going to be at this point. Then we move 4 units going upwards. So according to this scale, this is 2 units, 2 units here. This is 2, this is 2. So it's minus 1, 2. So we're going to end up at this point. Where we end up at, that is where your P1 is. And we end up at 2. And at that point, 2x is 0. So it's going to be 0, 2. So as you can see, you can even use your graph also by movement using your graph. Okay. So that was it. And describe fully the single transformation which maps PQ onto PQ onto P2, Q2. That is PQ, this one. And now it's going to be difficult for me to describe this because I do not have any, like this software does not have the gadgets for me to do these things. But what you're supposed to do, you know that you're supposed to join dotted lines. You just use even dotted lines here from P2 to P. You join your points, and from Q to what? To Q2, you join your points. So definitely, if you were to extend further, they were going to cross each other somewhere there. So that one was going to be a rotation. So remember your rotation, the lines are the same, and we have to find the center of rotation whereby you have to bisect. So now that is where we are having a difficult because you're supposed to bisect from P to P2. You bisect this line, you bisect QP and Q2, you bisect. Where those meet, that will be your center. So in this case, we are not having something exact because of what? Because of the graph that, because of the properties that we have here. Like this software does not have instruments. I shall try to work on other softwares which can give us instruments to even do all these construction part. But that was it for this part. You just have to, I think you can even proceed from there because guys, I talked about this type of transformations, rotation. Yeah. Number 24, we are given there are 10 students which walk to Chitsa High School every day. So these ones, they are walking every day to Chitsa. The distances they walk to the nearest kilometer are given in the frequency table below. So these are the distances, the distance in kilometer, then the frequency. State the least possible distance walked by a student. What is the smallest? The least is the smallest distance, and the smallest distance is what? Is 1 kilometer. That was the least distance which was traveled. Like the smallest distance. That's what they mean. Okay. Then B, the modal distance traveled or walked. So the distance now, the modal is the one with the highest frequency. So where do we have highest frequency? Highest frequency is here. So which means we are going back to that one again. So this one was going to be 1 kilometer again. All right. Then the median distance. So remember, guys, median, I told you that when you are using a graph like a table like this, median, you are going to use this formula, half of the distribution, which is half of n plus 1, where n is the total frequency. So it's going to be half of n. How many students are there? There are 10. So it's going to be half of 10 plus 1. And 10 plus 1 is 11. So that's half of 11, which is 5,5. So where we are going to have this 5,5, that is where our median is, where we are going to have this 5,5. So we have to count until we get the 5,5. So this is 4. We are not yet having 5. We are still less than 5,5. So we have to add 4 plus 2. So 4 plus 2 is 6. So which means this 5,5 is occurring here. So that's where our answer is, which is at 2 kilometers. Or you can even use this direction, 1 plus 1, that is 2. We are still less than 5,5. We add again, 2 plus 2, that is 4. So now you are at 4, still you are less than 5,5. The moment you add 4 plus 2, it's now 6. You have exceeded 5, which means this 5,5, it occurred in this region. And that region, what is the distance in that region? This is the answer that you need, the distance, which is 2, because we need the median distance. All right, so it is going to be 2 kilometers. Or what you can do, since you know that median is the middle term where numbers are arranged in order of size, you are going to arrange this in order of size. That will be the longest way that you can do in this paper. All right, what are you going to do? This is frequency. We are saying 1 kilometer was moved 4 times. So you can list this 1 4 times. That's 1. Sorry, let us list this 4 times. That, guys, is going to be the longest way that we can do this way in this, but we don't have option if you don't understand this one. So it's going to list 1 4 times. So we've got 1, we move on. We've got 1, we move on. We've got 1, we move on. We've got 1. There are 4 of them. They are appearing 4 times. 2 is appearing 2 times. So it's 2. That frequency means it appears the number of times. That is 2 times. 3 appears 2 times. So it's 3, which appears 2 times. We move on. 4 appears 1 time. So it's going to be 4. 5 appears 1 time. So this is going to be a 5, like that. So that's what you're going to have. So remember, the median is the middle term when these numbers are arranged in order of size. So it's going to be 1 here, and the 5 cancel, the 1 and the 4, the 1 and the 3, the 1 and the 3. So as you can see, we are left with these 2 numbers in between, which is 2 and 2. So the median, we just add 2 plus 2, divide by 2, which is going to be 4 over 2. Whenever there are 2 numbers, you add them, then you divide by 2. So as you can see, the median is going to be 2. So that is what we could have done, but you could have just used our table by just knowing this concept, or you can list them like that, what I've done here. Then you'll find the middle term, still you'll obtain the same answer. This is paper 1. You're not supposed to lose any mark from this question paper, actually. All right. Anyways, find the mean distance traveled. So mean is just like this. You can choose to use this concept. If you have listed these numbers like this, you can choose to add them 1 plus 1 plus 1 plus 1 plus 2 plus 2. You add all these numbers, then you divide by how many numbers there are 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is the number of what? Students which are there. So if we add this, we are going to obtain 23. So which means your mean, which is the average, is going to be 23 over the number of terms, which is 10. So it's going to be 2,3. So that's it. Or you can use this concept of the table. If you work it from the table like this, 1 appears 4 times. So you multiply 1 times 4. That will be your total. That is your total now. So it's 1 times 4. All right. We move on to the second one. It is 2, and 2 appears 2 times. So it's 2 times 2. So this one is going to be 2 times 2. All right, so that's 2 times 2 here plus, guys, all right. So let me try to remove this part here. So it's actually 2 times 2 there. All right, so this is 2 times 2. We move on to this one. It's 3, which is appearing 2 times. So it's 3 times 2. That is another way that we could have done this. So it's 3 times 2. All right, so that's what you're going to have. Then we move on to 4. It is appearing 1 time. So it's 4 times 1. The same with 5. 5 times 1, as we can see. All right, so that's what we are going to have in this case. So it's going to be 4. We said 4 and 1, then 5 and 1. All right, so it's 4 times 1 here plus 4 times 1 and 5 times 1. So it's going to be 5 times 1, like this. All right, everything over the total frequency. The total frequency does not change. That's the number of terms, which is what? Which is 10. So as you can see, we're going to obtain the same answer. So this was going to give you 4 plus 2 times 2, which is 4 again, 3 times 2, which is 6, 4 times 1, which is 4, 5 times 1, which is 5. So that's what you're going to have. You add everything over 10. And that was going to give us a 23 here in this case over 10, if you add this proper, which is 2,3. That was it. And that is the average distance, which is 2,3 kilometers, just like that. All right. So there were so many ways of answering this typical question, and also this type of a question, guys, I don't know how I'm gonna do it, but I'm just gonna explain what was it supposed to be, because we do not have the things here. 2 centimeters from BC, construct 2 centimeters from BC on the same side of BC as A. So you know this one you're supposed to measure 2 centimeters. Then from BC, you mark from this point B, you measure 2 centimeters, you mark, you do an arc. At C, 2 centimeters, you do an arc like that. Then you join these backs of the arc, these ones. All right, so that was supposed to be the way. It must be a parallel line. So this must join to this point here. So it must be actually a parallel line on the same side where there is A like that. And the other one was 3 centimeters from A. Remember, 3 centimeters from a point, you measure 3 centimeters. At that point A, you draw a circle. So this one is actually a circle. That is 3 centimeters from what? From A. So if you are to do this properly, you are going to be at point A. You mark from that point, stepping at that point, you draw your circle, which is 3 centimeters, just like that. And then you're asked to mark and label 2 points P and Q, which are 2 centimeters, which is this one. And there are 3 centimeters from A, which is this one. So you're saying where these two meet, where the circle and the line meets, that are the points that you're going to mark and label them. So it's this point and this point, and we label them P and Q. So remember, you're told to label them P and Q. So I'm just going to label this one P and Q. So this one is it's not accurate, guys. I'm just saying that is what you're supposed to do. So when you're supposed to do the exact thing, but here I'm just showing you what you're supposed to do in actual sense. So I want you to try that and see if you're obtaining the same or the exact thing. All right, then on number 26, that is the map of a scale of a house, which is given as 1:500. Find the length of a room of the plan. So guys, I told you that this scale simply means a centimeter on the map is representing 500 centimeters on the ground. That is what it means. So this is the 5 centimeter, which occurs on the map. This is actually on the map, and this is actually on the actual ground. So you convert from these 500 centimeters to the units that are there. In this case, we are given what? To find the length of the room on the plan, which is the map, which measures 8 meters. So which means our units were supposed to be used in meters. So let us convert this scale to meters. So that's the first thing that you're supposed to do. So 1 centimeter on the map indicates how many meters on the ground. So this is 500 centimeters. How do you convert to meters? You divide by 100, and this is going to be 5 meters. So we are saying 1 centimeter means 5 meters on the ground. So it means whenever we see a centimeter on the ground, we are actually seeing what? 5 meters. So these two are equal. And what about 8 meters now? This is now what you're asking yourself. What about 8 meters on the ground? What am I going to have on the plan? The plan is the map. The plan here is your map. All right. So that's what you're going to have in this case. So what are you going to have to find the value of the corresponding for 8 meters? So as you can see, it's going to be more. So it will be 8 over 5. So it's 8 meters over 5 meters multiplied by 1 centimeter. So the meter and the meter will cancel. So 5 into 8, that is 1. And we've got a remainder of 3. So it's going to be comma into 6, which is a 6. Here into 3, that's a 6. So it's 1,6 times 1 centimeter, which is 1,6 centimeters. All right, so this is the equivalence that you are going to have on the map. So on the map, you are having 1,6 centimeters, but on the actual ground, what we have on the actual ground, you've got 8 meters. That's it. Then calculate the actual height. Here we need the actual height that you are going to have. If the wall is represented by 3,6 centimeters on the plan, so what is the actual? Still, we are going to have a conversion from this because we are given the actual height. So we're going to start from this. Okay, so this is your B. 1 centimeter, we said it is representing what? 5 meters. 1 centimeter is representing 5 meters. What about the 3,6 centimeters? What is it going to represent on the actual ground? So 3,6 centimeters, what do we have on the actual ground. This is the actual height. So that is your meters. So it's going to be 3.6 centimeters over 1 centimeter times 5 meters. Make sure that you watch the video on scale and maps there so that you can understand this part, the basic of it. So the centimeter and centimeter multiply here 5 times 6, that's at 30. 5 times 3, which is 15. 15 plus 3, which is 18. Our main decimal place is 1. So it's going to be 18,0, which is 18. So that will be 18 meters. The comma 0 does not matter. All right, so that was it. Just like that. And we are now given to find the actual area of the room, which has got an area of 1.6 square centimeters on the plan. So what is the actual area? So we need area this time. So remember, guys, I told you that this is your scale factor. Whenever you are using sides and so forth, you use this because it's your scale factor. This one is your scale factor. But the moment you talk of area, which means you need area factor. So we are going to start with our scale factor first. We know that from this scale factor, we said 1 centimeter on the map, it represents, or it is equivalent to 5 meters on the ground. Here's 5 meters on the ground. So if it is equivalent to 5 meters on the ground, which is our scale factor, what is our area factor? We have to square this. So if we square 1 squared, it's going to be 1 square centimeter equal to 5 squared, which is 25 square meters. So this is now your area factor that you're going to use with what? With 25. So now your area factor is going to have 25 here. All right, guys, what is happening now? All right, so this is 25 square meters, like that. All right, so we are saying according to area, 1 square centimeter that is on the map is equivalent to 25 square meters on the ground. So what about this 1.6 square centimeters, which is on the plan? What is it going to give us on the actual area? So this is what you're going to ask yourself. So square centimeters under square centimeters. So this is 1.6 square centimeters. What are we going to have in square meters? That's what you're asking. So this is going to be more. So it's 1.6 over 1 times the 25. So that's it, 1.6 over 1 times 25 meters. So we're going to multiply 25 meters here. So if we multiply this, we are going to obtain 40. If we multiply properly, which is 40 square meters. So that was actually the case that we had in this case. So these are very important typical questions, guys. As you're answering your questions, you must be very careful. All right, so that's it. Let's see. Number 27, it was actually a curve of y is equal to 6 minus x squared. So this is the graph that we are given. Y is equal to 6 minus x squared. That was the equation of the graph. And we are given the first part to solve the equation 6 minus x is equal to 0. Use the graph. So you're using the graph. So to solve this equation, this is where your graph cuts the x-axis when they say is equal to 0, where your graph cuts the x-axis at this point here and at this point here. So at this point, as you can see, it's 1, 2, 3, 4, 5. So it's in between -2 and -4. So which means our x was going to be -3. All right. So in this case, our x here is at -3, or another one is at this point here, which is direct here at 2. So this one crosses at 2. That is the value of x there. Or your x in this case is at 2. All right, so that's what we had. Then B, state the equation of the line of symmetry of the curve. So remember, the line of symmetry is the line that divides the curve into 2 equal parts. So you can determine this by looking at the curve. Now it's going to be difficult for us because of this to draw the line. But it was supposed to be in between the line. I don't know, it's maybe somewhere there, but in between, you draw a straight line, guys. Just pardon this. part, but it's supposed to be a straight line from this part that you are given. That is what we're supposed to do. But because now of the graph that I'm having and so forth, like I do not have like a ruler in this case to use like on this instrument. So I'm not going to see the exact value, but that was going to be the value of x that you're going to take. So since we are in paper one, this is what you're going to do in a simpler way. To find this equation of line of symmetry, what you do is that you add your x-intercepts together, the values of x, which is your solutions. So your x is going to be, you add these two together, then you divide by 2, just like that. That is your line of symmetry. So you add the solutions, then divide by 2. So minus 1 here, because we've got minus 3 plus 2, which is minus 1. So it's going to be minus 1 over 2. So that is the value of x. So x is going to be minus 1 over 2 or minus 0.5. That was the equation. So always, if you are dealing with the line of symmetry, it's given in terms of x is because it's a vertical line. So it's x is equal to the value where it is crossing through that, that one. Okay, then estimate the maximum value of the function, that is c. So you're asked to estimate. So to estimate what you're going to do, that is where this graph, where we are going to have the maximum at the turning point here, where actually where we have got this value here. So that's where we are going to estimate our solution here. I mean, our maximum value. So you draw straight at the turning point of the graph, straight with your ruler to the what? To the graph at that point. So that was supposed to be the value where it crosses the y-axis, the value of y there. That is your maximum value. But as you can see, this value here, it corresponds with the value of x at the turning point here. So what are you going to simply do? We can simply substitute, if we are not exactly about this, we can simply substitute the value of x into the, because we know that the value of x at that point, which is the value of x at the line of symmetry, this one is the one that you substitute into your equation, this one. So that is what we could have done. So since we know that our equation is y is equal to 6 minus x squared. So you substitute the value of x at the turning point, which is the value of x of the line of symmetry. That is the one that you're going to use, which is minus 0.5. So by substituting this, you obtain the maximum value of the function. That is what it means. So this is minus 0.5 here, minus 0.5 in bracket squared. All right, so that is it, guys. You simplify, you square that one. After squaring it, you add, you subtract, and so forth. Both this is going to be minus and minus, which is a plus. So it's going to be 6 plus 0.5 here minus 0.5 squared. Minus 0, you simply multiply 5 times 5, which is 25. How many decimal places that you're going to have? There are going to be 2, because this one is going to be 0.5, 0.5. So it's going to be 0.25. So you subtract 0.25 at the end. So if I add these two, it's going to be 6.5 minus 0.25. So this one gives you the exact value. That is the advantage. Yes, it's long, but it gives you the exact value. And if you subtract 0.25 from 6.5, you are going to obtain 6.25. So that is the value of y at the maximum point, or at the turning point. That is our maximum value that we are going to have in this case. So this was actually what we needed in this case. Okay, so let's see another part, which is D. Estimate the area bounded by the graph, the x-axis and the lines x is equal to -1 and x is equal to 1. All right, so for area, guys, this is what you're going to do. Area, let's see, but this part is area bounded, which is area between the graph and the x-axis. So, which means we need this region first. Between the graph and the x-axis, that is what we need first here. Let us just try to remove this part so that it can help us now to find the exact value. All right, so between the x-axis and the between, that is just by just being bounded by the graph and the x-axis, which means we are referring to this region here. This is the region that is being bounded here. That is something like this. This region between your x-axis and the graph. All right, so something of this nature. All right, so this is where in between that graph that you have, All right, and the x-axis, something of this nature. So this is the region that you're going to have. But in between this region, we are given a further statement to say, and the lines x is equal to -1 and x is equal to 1. So we need in between these two. X is equal to -1, that is 1, 2, 3, 4, 5, somewhere here. So this is the line of x is equal to 1 here. So this is the line of x is equal to -1, sorry, that is x is equal to -1. Okay, so this is where we are going to have the line of x is equal to -1. Okay, and x is equal to 1 is between 0 and 2, so that's 1, 2, 3, 4, 5, somewhere here. We draw our line, that's somewhere here. All right, so that's what you're going to have. This is the line of x is equal to 1. So which means you need the area in between this region here. This is where you are going to have your area under this graph. Okay, so what do? You calculate these boxes which are in this region. Okay, you calculate all these boxes. So here I actually calculated and I just calculate, guys. I don't know what you're going to have because yes, like a lot of things that you're going to have, but if you calculate, you get whatever that you get in this case, that is going to be fine. So if I calculate fine here, I got something like 102. So whatever number that you're going to get is an estimate. Take note, guys, an estimate. All right, so you're estimating this answer, but it must be actually be in the range. Okay, so our area is going to be the number of boxes that we have calculated according to you over 100. So this is your formula, number of boxes over 100 times. We know that we multiply by the area of the unit square, and the unit square in this case is the first box that we have here, which is this box that we have. So which means the area of the unit square in this case is going to be this part here. Let me just remove this part so that we can clearly see the area of the unit square. Which area is that one? This is the unit square. That is one that you use. You simply calculate this box here. The first square, which is at 5, here we are at 5. And here we are at 2. So this is 2, this is 5. So you multiply 5 times 2, which is 10. So that is the area of the unit square, which is the first box, this one, the first box, which is 10. 5 times 2, which is 10. All right, so that is what you're going to do. You multiply by that area of the unit square, which is 10. So that's what you can obtain at the end. And this is going to give us 10 into this, which is something like 10,2. So like I said, count the boxes according to your graph there. Make sure that you count all those boxes properly. Yeah, that can actually help. Okay, so that's what we had, guys. That's our last question of the paper, which was on number 27. So that's what we had, guys. So as you can see, all we need, guys, is to revise as much questions as possible, work in, revise as much as you can. That is the best way that you can do. So that's it, guys, from Memo African Motives, working on O-level mathematics, revisions, question papers, preparing ourselves for the exams which are to come. So make sure that we revise, guys. We do not have time. Always we are behind time, so we need to cover up as much as we can so that we prepare ourselves for those exams. So, but for now, that's it, guys, till we meet again.